Have you ever stopped to think about what's actually going on behind the scenes of an app like WhatsApp or Messenger? Well, today we're going to do just that. We're going to design a chat system completely from scratch, and not just any chat system, one that's powerful enough to connect 50 million people in real time. All right, let's dive in. Yeah, you see these logos every single day, right? They're on your phone, you probably just used one, but behind these super simple icons, wow, there is some incredible engineering complexity. Our goal today is to pull back the curtain and really understand the core ideas that make them all tech. And we are not starting small. The challenge we're tackling, we need to design a system that can handle 50 million daily active users. I mean, just think about that number for a second. That is a massive, massive scale. And that scale, well, it forces us to make some really specific, super important design choices right from the very beginning. So, okay, where do we start? Well, just like in a real system design interview, the absolute first and most critical step is to figure out exactly what we're building. We got to define the scope, right? We can't build the entire universe at once. So what are the must-haves, the non-negotiable core features our app has to have on day one? All right, here they are, our 5 core functional requirements. First up, the basics, one-on-one and group chats. We'll cap groups at 100 users for now. That's our main thing. Second, we need that little online dot, right? So presence indicators. Third, multi-device support. You got to be able to use it on your phone and your laptop. Fourth, push notifications, to get people back into the app when it's closed. And finally, the really big one. We have to store chat history forever. Yeah, forever. And you can probably guess that last one is going to have some huge implications for our database. Okay, so with our requirements locked in, we can finally start sketching out the architecture. Let's get our hands dirty and see how we go from just a simple idea to a high-level design that can actually handle all 50 million of our users. At its absolute core, a chat app is basically just a mail carrier. It's this simple. You've got a sender, a receiver, and our chat service sitting in the middle. The service's only job is to take a message from the sender and then pass it along to the right receiver. Sounds easy, right? Well, when you're doing that millions of times a second, things get just a little more complex. And this is what that complexity looks like. To handle that massive scale, we have to break our system into specialized little workers. We've got API servers that just handle things like logging in. We've got notification servers whose only job is to send out push notifications. And then there's the heart of it all, the real-time service. Even that is split into chat servers that actually pass the messages back and forth, and presence servers that keep track of who's online. And holding all this together at the very bottom is our database, which you can see is a key-value store. So that brings us to our first major technical hurdle. Let's go back to that store chat history forever requirement. For 50 million users, that means we could be dealing with, well, trillions of messages over time. So the question is, how on earth do you store that much data and still find an old message in, less than a second? This is a huge, huge decision for our database. So let's break down our options here. On one side, you've got your traditional SQL database. These are great, but they really struggle with what we call horizontal scaling. That's just a fancy way of saying it's hard to add more machines to handle more traffic. On the other side, you have a NoSQL Key-Value store, which is built for that kind of thing. It's designed to just add more computers as you grow. It's also way faster for this kind of work and much better at handling the long tail. All those old chats from years ago that people rarely look at. So for what we need, the Key-Value store is the clear winner here. And look, we're in pretty good company with this choice. This isn't just some theoretical idea we cooked up. The absolute giants of the industry. We're talking Facebook Messenger, Discord, apps that handle a mind-boggling amount of data every second. They both rely on key-value stores. So the key takeaway here is that this is a proven, battle-tested approach that we know works at an insane scale. Okay, so let's peek under the hood at how we'd actually structure our data. For a simple one-on-one chat, it's pretty straightforward. The message ID is the key, and that keeps all the messages neatly in order. But for group chats, we do something a little different, and it's kind of clever. We use what's called a composite key, made up of both the channel ID and the message ID. And what this does is it physically groups all the messages for one specific chat channel together in the database. Why does that matter? It makes looking up a conversation way, way faster. All right, so we've got our storage figured out. Awesome. But now for the next giant challenge. How do we deliver messages instantly? And that word instantly is the key. This is the real-time problem. When a message hits our server, how does your friend's phone find out about it right now with zero delay? Well, the most basic, old-school approach is called polling. Think of it like a kid in the back of a car on a road trip. The app just constantly asks the server, "Any new messages yet? How about now? Any new messages?" over and over. And most of the time, the server's answer is going to be, "Nope." This wastes a ton of data, a ton of server power, and it's an absolute battery killer on your phone. Just not a great solution. Okay, so a slightly smarter way to do it is long polling. Here, the client asks for messages, but the server basically says, "Hang on, I'll keep the line open and I'll tell you as soon as something comes in." It's definitely an improvement, but it still has its own problems. For instance, what if the specific server holding that connection open crashes? The client is just left hanging. It's better, but it's not a truly permanent, stable connection. And that brings us to the modern, elegant, and really the best solution for this, the WebSocket. So here's how it works. The client starts a normal connection, but then it does this special handshake with the server to upgrade it. And what that creates is a persistent, two-way communication superhighway. Now, the server can just push messages down to the client instantly the second they arrive, without the client ever having to ask again. That ability for the server to push data, that's the whole ballgame. So let's just define that properly. What is a WebSocket? It's a full duplex communication channel. That's a fancy term that just means data can flow in both directions at the exact same time over one single long-lasting connection. It's like a phone call, not a walkie-talkie. And honestly, this is the core technology that makes pretty much every modern real-time app you use possible. All right, we've picked our database, we've got our communication protocol, we have all the puzzle pieces on the table. So now, let's put it all together. Let's follow a single message on its entire journey through our system, from the very second someone hits send to the moment it pops up on their friend's screen. Okay, let's trace the path, step by step. Step 1, user A sends their message. It goes straight to the chat server they're connected to. 2, that server immediately gives the message a unique ID. 3, the message gets put into a queue to be processed. 4, it's saved forever in our big key-value database. Now, step 5, the system checks, hey, is user B online? If they are, the message gets forwarded to their connected chat server. And finally, step 6, user B's server pushes that message right down the open WebSocket to their device. And boom, delivered. But wait, what happens back in step 5 if user B isn't online? What if their app is closed? Well, if they're offline, the system takes a totally different path. Instead of even trying to use a WebSocket, it hands the whole job over to our specialized notification servers. Their only job is to send that familiar push notification to wake up user B's device and let them know they have a message. Okay, we've totally nailed messaging. But what about that other core feature we talked about, that little green online dot? How does the app actually know if your friend is available to chat? Well, that's where our presence servers come into play. So here's a really common problem we have to solve for this to work well. You know how your phone's connection can be, well, terrible sometimes? It might drop for just a few seconds when you walk into an elevator or drive through a tunnel. We can't have your status just flickering back and forth, online, offline, every time that happens. That would be an awful user experience. The solution is actually a pretty clever little trick called a heartbeat. As you can see here on the timeline, your app is constantly sending a tiny little, "Hey, I'm still here," signal to the server, maybe every 5 seconds. Now, if the server stops hearing those little heartbeats for a longer period of time, let's say 30 seconds, only then does it finally say, "Okay, I guess they're really offline." This little buffer, this grace period, is what smooths out all those annoying brief network hiccups. And that's really the whole point. This simple heartbeat idea is the entire reason your friend's online status seems so stable and doesn't change every single time they drive through a tunnel. It's a small thing that gracefully handles the messy, unpredictable reality of mobile internet, and it makes the experience so much better for everyone. So, there you have it. We've designed a pretty robust system for text messages. But what about video? I'll leave you with a final question to chew on. If we wanted to add real-time video calls to this app, what single part of our architecture would need the most radical, fundamental change? Think about it, because the answer really opens up a whole new world of system design challenges.